Oh my God. No. Can I go to the nurse? Can I go to the nurse? I'm getting a headache just like that.
Related rates.
No, it's just
Trig.
Trig that's a problem, right?
I'm not worried about related rates. I'm worried about putting Trig in the rate.
Yeah, I just can't do math. I can't
Who
like
invented
calculate
Trig?
things.
Okay.
Mistakes are just like.
Did you guys spend some time here to copy down those notes?
Can't even read some of them.
Wait, what is that second word?
What is the first one?
List known and unknown variables. Yeah, I'll read it out to you. I know it's a little bit faint. So here are the steps for related rates. We've seen related rates before. We just now have to look at it from a trig perspective. But we may do these in different orders, but these are the steps that we're going to all have to take care of. We have to list known and unknown variables. Rather, we're just gathering information from what is provided in the problem. We write our trig equation relating the variables together. So before we were doing taking out equations that were related to either algebraic or geometric equations, right? So Pythagorean theorem. We've seen ladder problems, right? X squared plus y squared equals z squared. And then the derivative. Everything is time, has time component, right? X squared becomes 2x dx dt. Y squared becomes 2y d attached dy dt. Z squared becomes 2z dc dt. So we've done problems involving Pythagorean theorem. We've done problems involving volume of spheres, right? Area of triangles, area of a rectangle. So we always have some equation that we start off with, and then we move on to the calculus portion. Okay, third step, differentiate with respect to time. That just means that we find the derivative, and the time component begins to appear. And finally, we're going to use trig ratios to substitute in the values and solve for that variable. Okay, does anybody still need to look at these notes? Yeah. Which one? Number 4 says use trig ratios to substitute in values and solve for the variable. I'm sorry? Yeah, I'm out. Yeah, so if you can just follow along. Okay, so let's look at example 1. Okay, so example 1, let me read this problem here. It says the fish is being reeled in at a rate of 1 foot per second from a point 15 feet above the water. At what rate is the angle between the line and the water changing when there's a total of 25 feet of line out? Okay, so here's our diagram. We're always going to be involving a triangle, but now what's different is that we have theta involved in our diagram. Okay, so fish is being reeled in. So we can imagine this line is getting shorter over time. This 15 is going to stay constant. But as the line gets shorter, we can imagine this increasing as the fish gets closer and closer, right? You can imagine this angle is getting steeper and steeper. Okay. So let me draw the diagram on a separate sheet here, just so I can have more room to work. Okay, so here's my triangle. 15 is the constant, theta is the variable, and z is also the variable. So I like to just start off, let's just have an equation so that we can kind of work from there. All right, now anytime a theta is involved, we have to pick either sine, cosine, or tangent to use. So which trig equation is most suitable for this situation? Sine, cosine, or tangent? Sine, right? Sine of theta is opposite over hypotenuse. That will allow us to hit both the sides that we have information about. So there's our starting equation. Okay, we're going to find the derivative of that equation. We'll come back to that. Let's just see if we can go back to the problem and start listing out the variables that is involved here. All right, a fish is being reeled in at a rate of 1 foot per second. So what can we assign this value to? Good, you know that fish is being reeled in is related to z, but you see the word rate, so you know it's going to be dz over dt. Any adjustment that we have to make with dc dt? It's negative because z is shrinking, right? Z is shrinking. This line is getting smaller over time. Okay, at what rate is the angle between the line and the water changing? What are we looking for? D theta dt. When there's a total of 25 feet of line out. Z equals 25. Now, careful, we don't want to insert 25 into the equation because we don't want to lose the ability to find a derivative. So we are going to use that 25, but not too early, okay? We want to hold on to that z at least until the derivative is found, and then we can feel free to start involving the 25. Okay, so we have everything that we need. Let's move on to our derivative process. Before we find a derivative, though, is there anything that we can do on the right side so that we can maybe avoid quotient rule? Okay, bring the z up, make it z to the -1. That way we can just rely on power rule, right? There's no need to involve quotient rule when power rule is sufficient. Okay, we're ready for our derivative. Remember, related rates, right? So there's always a time component that's going to show up for every derivative. Sine theta becomes right, just like with Pythagorean theorem, right? X squared became 2x dx dt. Same thing here. Cosine theta, sine theta becomes cosine theta d theta dt. All right, right side, power rule. To the -2 multiplied by dc dt. Okay. Now, if we look, this is the only calculus in the problem here. Now we're just trying to figure out how to substitute all these values. D theta dt, that's our goal. That's what we're looking for. Z is 25, so we have a substitution for that. dz dt, we have a substitution for that. So really, the only thing that we have to account for is figuring out how to replace this cosine theta. Okay, so what I want to say is that don't worry about theta. I think what students get caught up is what's theta, right? They're trying to figure out what theta is. Don't worry about theta. You're going to replace the entire cosine of theta. Replace the entire. We're just going to find a trig ratio for cosine theta. Okay, so that's the big thing that I want to make sure that we, big hurdle that we want to make sure that we are able to to clear that we're not worried about theta. We want the entire cosine theta to be replaced. So what we're going to do is we're going to draw a separate triangle just for the trig ratio, okay, so that we don't get all, so it doesn't get too messy with our diagram. Okay, we already have the 15 involved. Okay, what is z at this moment in time? 25. So what can I do to find this third missing side? Pythagorean theorem. A squared plus b squared equals c squared. So let's do that. This is a variation of the 3, 4, 5 triangle. Okay, good so far? Now, look at this triangle here. What's cosine of theta for this? Cosine of theta equals 20 over 25. And what does that reduce to be? 4/5. So we're getting close. This is all we need. This is the only thing that's different about related rates for trigs. Just trying to draw the second triangle so they can pull that ratio out to get that trig replaced. Okay, we'll do some cleanup along the way here. Gonna bring that z down to the denominator. Okay. Dividing by 4/5 is the same thing as what? By 5/4. So I'm going to bring that reciprocal over. And I'm going to start making substitutions on the right side as well. I'm going to replace z with 25. dc dt with -1. And then that 4/5 is going to come over as 5/4. Okay, the two negatives cancels out. I'm just going to see if I can. Sorry, 15 times 5. I'm going to break this down a little bit more so I can cancel some things out a little bit easier. 15 is the same thing as 5 times 3. There's a 5 there. 25 times 25 times 4. 5 times 5 is 25. I can cancel that out with one of the denominators there. So this is 3 over 100. Okay, theta for our purposes will always be in terms of radians, never degrees. So our units of measure, theta is going to be radians. But then what's our time component? Yeah, time is seconds, yeah. Okay, any questions here? Okay, so these will be the pattern that we're going to step through with our problem. Okay. Okay, we're going to skip number 2 and go to number 3. We'll revisit the ladder problem, and then we'll bring in the theta component, the angle component into it. Okay, any questions with 1? Yeah. Radians per second. Yeah, never degrees. Will always be working with radians. Okay. All right, so back page. Page 11, number 3. We'll just do parts A and C. Okay, does anybody still need this? Okay, so part A should feel familiar. This is the most commonly worked problem for us, these ladder problems here. So ladder 50 foot long is being pushed against the wall at a rate of 5 feet per second. Okay, Pythagorean theorem. Derivative time component shows up as each derivative gets found. Okay, go ahead and list out all the 6 variables that in play here. Okay, let's see if, how much of this we can fill in here. A ladder 50 feet long. Where does that go? Is being pushed against the wall at a rate of 5 feet per second. What is that? Yeah, dx dt, all right, being pushed against the wall here. Any adjustment that we need to make with that 5? Yeah, that x is shrinking, right? That x is shrinking. When the bottom of the ladder is 30 feet from the wall, 30 is x. What is the velocity at the top of the ladder? So we know that the ladder is going to move up. It's going to cause the y to change. And we know that's our trying to solve for dy dt. Okay, what's dz dt? What's the rate of change of the ladder? Right, 0, right? That ladder is going to stay 50 at the beginning of the problem to the end of the problem, so it's not going to change at all. Okay. How can I find y? Pythagorean theorem. This is a 3, 4, 5 triangle, so 40. Okay, so start filling everything in. Oops, dz dt is 0, right? I'm going to place that with 0. Okay, do some cleanup here. Negative 10 times 30, negative 300. Right side is just 0. Okay, so that's part A. We found dy dt. So now let's go to part C, involving rate of change of the angle. Okay, any questions? All right, part C. says, at what rate is the angle formed by the ladder and the floor changing? So we're trying to find that d theta dt. I'm going to redraw the diagram here just with what we need. Okay, so we're trying to find d theta dt. Now, we actually can use any trig function here. We have more than enough information where we can do tangent, sine, or cosine. But here's my suggestion. My suggestion is always, I mean, if possible, try to involve a side that has a constant. Okay, that may not always be the case, but if you can involve a constant, that means you can avoid quotient rule. So what's the constant in this problem? That 50, right? So I would say try to avoid tangent in this case, right? Because anytime that we can involve 50, we'll have an easier time with our derivative. So either cosine or sine is good. Let's just do sine. I mean, you can do cosine and be fine, but let's just work together on the same, follow the same process here. Okay, so let's find a trig equation here. Okay, how would you set this up? Sine theta equals y over 50, yeah. Okay, everything that we need is already available from part A. So we'll go ahead and move into our derivative step. But before we find the derivative, what can we do to maybe rewrite this so that we're not thinking about quotient rule? Yeah, push that 50 out as what? Yeah, makes it easier visually, right? Sometimes we're looking at this, maybe it's not very apparent how to find the derivative. But once you get that 50 to come out, it becomes more familiar, right? It's just a number that's sitting in front of a variable rather than below it. Okay, derivative, sine theta becomes? Good. Time component shows up for every variable. 1/50th times y becomes? Good. The coefficient stays. The y goes away to 1, but we're asking for y's derivative, so we don't want to forget about dy dt. So if we look, we're trying to solve for d theta dt. That's the missing variable. We have dy dt from part A, and now we're just trying to find a suitable replacement for not theta, but cosine of theta. Okay, so let's step to the side here, create a triangle, and fill out all the sides so that we can find the ratio. Okay. This is a 30, 40, 50 right triangle here. So 30, 40, 50. All right, what's cosine of theta?
30.
Yeah, adjacent over hypotenuse. 30 over 50 reduces to be 3/5. So now we're nearing the end. It doesn't matter, but without a calculator, maybe I'll just go after the 30 over 8. Makes it easier for me to work with. Okay, how can I bring that 3/5 over? Yeah, reciprocal. So if I can break everything down into easier parts, I can make this 10 times 3 times 5, 10 times 5 times 8 times 3. A bunch of things will cancel out, makes it easier for me to reduce. 10s go away, 3 goes away, 5 goes away. What's left? 1 over 8. Units of measure. Mm-hmm. So I see students run into trouble when they try try so hard to figure out what theta is, but again, don't worry about theta. All you need is a separate triangle, find all the missing sides, Pythagorean theorem through it, and then use SOHCAHTOA to find the replacement for your trig function. Okay, questions? Okay, all right, I got 2 more problems for us to do. If you guys can turn to page 12. And let's try 38. So read the problem, but I will walk through the steps with you as well.
What was the unit for the rate change the angle? Is it radians over second?
Yeah, radians per second.
Okay, thank you.
Okay, reading the problem here. A balloon rises at a rate of 4 meters per second. Okay, again, we're at page 12. From a point on the ground 50 meters from the observer. So we have the balloon that's rising. Observer is standing 50 feet horizontally from where the balloon begins to rise. Find the rate of change of the angle of elevation of the balloon from the observer when the balloon is 50 meters above the ground. So let's go ahead and create our trig equation here. Which trig equation can we use that will hit theta, y, and 50? Tangent. Okay, so here we have to use tangent here. Okay, before we find the derivative, let's go ahead and find all the information that's related to this problem. A balloon rises at a rate of 4 meters per second. What can we assign that to? Yeah, dy dt, right? Y is changing, balloon is rising. Positive, right, is that y is increasing. From a point 50 meters from the ground, we have that already. Find the rate of change of the angle of elevation. We're looking for d theta dt. When the balloon is 50 meters above the ground, so moment in time, 50 is assigned to what? Y. Okay, but don't put that 50 into the equation. We don't want to lose that y. We want to find the derivative. Okay. Okay, we're ready for our derivative. Let's rewrite that right side. We don't want to have to deal with quotient rule, so just make this what? 1 over 50 times y. Feels a lot easier writing it out in that form. Okay, ready for our derivatives. Tangent theta becomes secant squared theta times what? Time component. 1/50th y becomes 1/50th dy dt, okay? Okay, let's see what we have here. Dy dt, we have a perfect substitution for that. D theta dt, that's what we're looking for. So we're trying to figure out a replacement for that secant squared theta. Let me just remind us, though, that it's really secant theta that we're looking for, and then we can square that once we find that replacement. Okay, so onto our triangle. Let's go to our triangle and see if we can find a replacement for secant theta. So 50 and 50. If you recognize this as a 45, 45, 90 triangle, you can find a hypotenuse, but Pythagorean theorem can also get you there. So 50 root 2 is the hypotenuse. Okay. Let's find a replacement for secant theta. Now, secant is related to what? Cosine. Cosine is adjacent over hypotenuse, so therefore secant is hypotenuse over adjacent, okay? Okay, what does that reduce to be? Just root 2, right? 50 goes away. All right, so now back to our equation here. Let's make our substitution. Secant theta gets replaced with root 2. Yeah, once you square it, yeah. 1 over 50. And then dy dt, which is 4. Okay, root 2 squared is 2. Dividing by 2 is same thing as, yeah, multiply by 1/2. Four over 100 reduces to be 1 over 25. Units of measure is radians per second. Yes. Which one? Oh, yeah. Because the 4 is coming from dy dt, so I need to make that substitution, bring that down. Okay, good. Any other questions? Okay, final problem here. I want you guys to try 39. 39 is going to feel like the first problem that we did. It's just different numbers. I just want you guys to see if you can try a problem on your own. Okay, so 39. I'll come around and see if you guys need any help, and then I'll go over this in detail with you as well. Okay, page 12, 39. Look back at the first problem if you like. It's the same process, just different numbers. Oh, yeah, yeah. Negative. It's coming in, so therefore that x is decreasing. Right, good. Make sure you hold on to your variable though when you create your trig equation. That 25 is not going to use till later.
Yeah, I'm saying. Yeah, that's what I'm saying.
Very similar to the problem that we just did at the very beginning of class. X is 25, dx dt is -1, right? That line is shrinking. We're looking for d theta dt. We want to target sine because sine will allow us to hit 10 and x, opposite and hypotenuse. We'll bring that x up to the top so that we can rely on power rule rather than quotient rule. And then sine becomes cosine theta, d theta dt. 10x to the -1 becomes negative 10x to the -2 dx dt. And now we go to our triangle. Opposite is 10, hypotenuse is 25, Pythagorean theorem. A squared plus b squared equals c squared. 625 minus 100 is 525. We just used 525, root 525. Okay, so what can I replace cosine theta with? Adjacent over hypotenuse. Okay. And then everything else should just be a matter of just plugging in. Right, make sure you bring that x to the -2 back to the denominator and then put 25. Dividing by that fraction is same thing as multiplying by the reciprocal. We can bring that root 525 over 25 over as 25 over root 525. And just go through your cleanup stage. Negatives cancel out. I can get one of the 25s to go away as well. So I have 10 over 25 root 525. But I won't take off points with if you have unreduced answers, right? So yeah.
So if you look at the 10 over 25 squared.
Yeah, that's fine. Yeah.
Okay.
Same thing with AP exams. You're never going to be penalized if your answer is not simplified. So.
Um, 5.5 is supposed to be 25 squared.
25 squared is 625.
So
So 625 minus 100, I got that 525. Okay, any questions here? Okay, so we've done part of the homework. If you look at the top of this page, it's 38, 39, 40, and 41. Those are your homework problems. And the back page is the last two problems. I will send out a link to the key so you can check your answers for 40 and 41. You can do it directly on this sheet if you like. Okay, so tomorrow is our final new topic. We'll do inverse trig derivatives. And then we'll have all of next week to review for our test. Thank you.